talk yesterday.
Okay.
Okay, good morning to all of you, friends. And it's the last day of our faculty development program. And it was so nice of you all that you have cooperated, and then we have a very good faculty development program. It's a sort of a good learning experience for all of us. And today we have one more mathematician with us, and he is a very kind and very loving personality. And I had an experience of spending 3 weeks with him in his place, Durban, where I have very fond memories of my along with him, and and Atlantic Ocean, along with the Atlantic Ocean. So we had a very good time and very good academic discussions also, along with another Brazilian professor, and we had some tripartite research collaborative initiatives over there. So meet Professor Oludoya Olugbara. He is a professor and executive dean of the Faculty of Accounting and Informatics at the Durban University of Technology in South Africa. So that's acronym is DUT. He is as I said, is basically a mathematician. Completed his PG, and a scholar one is a scholar person. So we are meeting all scholar people over here, and he has a very creative and innovative personality, very enthusiastic personality, and he has been awarded many awards, like he's been accorded with many awards. He has got a Meritorious Research Paper Award in 2012 at the International Conference on Machine Learning and Data Analytics, organized by International Association of Engineers in San Francisco, USA. And in India also, he was awarded with a outstanding scientist in 2015 by an NGO in India. And then he has a very vast publication. He has more than 180 research papers, books, book chapters, and conference proceedings. He has guided to 15 doctorate students, and it's a good news for all of you. Like his university offers a postdoc also. So those who are interested can apply over there. So he has given guidance to four postdoc fellows also, and a postdoc fellowship is offered by his university. So that way he is a very resourceful person, and he is reviewed many. Is an international reviewer on many journals, reputed journals, and he has started an initiative called as ICT and Society. It's a research group in his university, and many more things are to be there. But like it's like they say, they judge the person when they are on dais instead of like reading about him. So I invite Professor Olu to present his presentation. Thank you, Olu.
Yeah, thank you very much, Professor Manas Joshi, and I'm really very happy to be invited to present in this workshop. And I do believe that you have enjoyed these 6 wonderful days you started this program. First, I think I thank you for the excellent introduction. I've been with Joshi for some time now, and we have very good relationship as colleagues and friends. And I was also in India about 2 times, and I stay with him. So I know the mother, I know the beautiful wife, and the family members. So Joshi is a very good friend, and I'd like to thank you for inviting me to speak on this program. So when you invited me, there was so much commitment for me and many meetings, but because of the respect that I have for you and whatever program you organize, you invite me. Even if I'm sick, I would like to be there. So that's why I chef almost every assignment, and then I accepted this one. So thank you very much. And participants, I say good morning to you. It is 6 o'clock in South Africa, 6:30 in South Africa now, and about 10:30 in India. So thank you very much. I do hope that you will have a wonderful time with me. So I'm going to speak on the topic, data science methods for intelligent business intelligence. And before I do that, I would like to briefly introduce you to my university. My university is called Durban University of Technology, and of course we have a very powerful vision, but more importantly is the ranking and the reputation that we have gathered across the world, and with many good rankings within the last 2-3 years at the university. For example, you can see Durban University of Technology, we rank 51 to 100 in terms of World University Impact and Ethical Value ranking, and of course, we are among 201 to 300 in terms of real impact university. So we generate impact within the society, and of course, societal impact is one of the elements of DUT. So we also rank by Times World University ranking in 2021, 2022, and of course, we came number 104 across the world, and of course, we again rank among Times World University ranking among the 400 and 500 universities across the world. So from the Africa, we are we are among the top 5 universities in South Africa. And of course, we are the best university of technology in the entire African continent. So we rank 12 position. In 2021, we ranked 10 position in the world. And when this number increased, the number of participants actually increased. In 2022, we became number 12 in the world in terms of global citation. So we do very good and quality research in our university. So the purpose of this lecture this morning is to explicate the connotations of data science, business intelligence, compare them, and introduce data science method for business intelligence. So to do this, I have quite a number of issues that I'll be discussing here. Of course, I call them melodies. So because I feel that you will have a pleasant time and you will enjoy them. So these are the topics that are actually related to data science and of course, business intelligence. And I'm going to be showing you today the relationship between both of them. And in summary, you will be convinced that business intelligence is a very small component of data science. Data science is the father. And of course, the business intelligence is the son of data science, data science. So I'll be discussing on quite a number of interesting topics and even new ones. And some of the research, I'm going to show very few examples of some of the research that I have done in data science and this area. So how do we define data science? I think that's the fundamental. And that's where we must start from. So data science can be defined as interdisciplinary field that uses advanced analysis methods. If you like, you can call it analytics method. And then also use some scientific principles and rules and theory for extracting, manipulating, visualizing data with the goal of supporting strategic planning and decision-making in any organization. So, and if you look at the picture I'm showing, so it's interdisciplinary in the sense that we use scientific method, we use data engineering approach, we use mathematics, and mainly it relies heavily on statistics. In fact, you will see later on, I mentioned that some authors are advocating that the data science should be called statistics should be now called data science because it really involves, and the backbone of data science is the statistics. So the next important thing in data science is the issue of data itself. So data itself is the first foundation of data science. And then that brings us to really find out what are the sources or where can we get data. And here, very simple, data are everywhere. Sometimes you can see them as big data or dark data. I think that also interests me. You will see the idea of dark data as we go on. And examples of data, actually, road accident. When there is a road accident, we can collect some data from there and use that data to do some analysis. We have data from water, ocean, for example, water coming from systems and applications, data coming from monographs, atmospheric air, data is in the air. And of course, data can also be from corpora. Corpora here simply means some databases on the internet, and then you can see. I'm just trying to show you an example of data world. So in data world, there are quite a number of data you can source here, and some of these data can actually be used for your experimentation and for your research. So, so data can be everywhere. Of course, we extract data from the air or water using sensor devices. We know from the Internet of Things or from Fourth Industrial Revolution, sensors and actuators become very important. Drones, again. So we can use the equipment to actually collect data from the air or from the ocean, and then they are used in applications such as Internet of Things. An example will include air monitoring, aircraft detections, road extracting road and trying to find out if these roads are in bad condition. So you can actually use some of this equipment to collect this information, and then you process the information that you collect or data that you collect to have useful information. So air data, for example, provide accurate information on quantities such as pressure, altitude, vertical speed, calibrated airspeed, true airspeed, and so on and so forth. And this information can be used to fly aircraft or for some other important applications like military applications and so on. Then what are the applications of data science? Data science has quite many practical and useful applications in the real world. I just try to look at few ones here that might interest you. The first one is fraud and anomaly detection. And of course, we can detect fraud mainly in accounting data. And then quite here in South Africa and in many parts of Africa, some people are not convinced about COVID, saying COVID is not true, it's government gimmick. And then if you want to find out whether the information reported weekly by World Health Organization is valid or not, or if this data is manipulated. For example, you can use data science method to actually find out COVID data and then find out whether this information is reliable or not reliable. Then personalized recommendation. Everybody now want to use computer or information systems for personalized recommendations. Sometimes I use my device, mobile phone, to actually tell me when I need to go and do my physical exercise, drug intake, product item from the market. I've done quite a lot of research on product recommendation, website recommendation, and of course, you can also do pattern recognition to find out purchasing behavior of customers, factor classification, if you are doing impact analysis or risk management, sentiment analysis. For example, you want to know what are your customers saying, what is their view, what is their opinion on the service that you render. And of course, conversational system is very important these days. We are very familiar with chatbot, and Alexa is very popular. And of course, humanoid. Humanoids are future technology that will be, of course, some people already begin to develop quite a number of them. As we go on, where we can see here that DT, we're also interested in, we have quite a number of robots, and we have been working on a humanoid instructor to actually develop assistive technology that will help our students to explain instructions to them in English. Many of them will prefer to use their natural language. For example, South Africa has 11 official languages. So we are constructing robots that will help our students to help them learn in their mother language. So this is the idea of humanoid instructor. And of course, robot, we take most of these functions that we human perform, like humanoid CEO of organization. So robot can actually lead an organization and advise and then give us instruction on what to do. We can also use this kind of technology in medical diagnosis. Like you see, robots will now be performing medical operations and probably guiding patients. And of course, we expect that the accuracy of medical diagnosis here will be more than that of a human. Then there's also very important natural language processing. It will also help, these methods will also help to be able to translate. The word is highly multilingual word. And of course, to translate from one language, and for example, if you need to translate Hindi to Marathi or Tamil to English, and of course, we can develop methods and of course use existing methods, for example, to actually construct systems of machines that can help humans translate from one language to another. Information retrieval becomes very important with the advent of cyber security. And of course, crowdsourcing also, we can use information systems to actually collect information from anywhere, from people who are sometimes not even aware that information is being collected from them. So I will try as much as possible to make this presentation interactive. So now, data science tools and platform. I'm sure you should have learned about some of them. There are quite a number of these tools and their platform. We know, for example, data platforms and engines that you can use, analytic engines. Quite a number of them. I know Hadoop is very popular. Spark is also there. And of course, NoSQL databases. Web platforms such as Jupyter Notebook, you use this for sharing documents that can contain quite a number of interesting information like code, equations, and so on and so forth. Machine learning platforms and library. This is very popular nowadays. Most people want to do programming, and then they want to use existing tools. There are quite a number of libraries and tools that you can and platform. Example is TensorFlow is very popular and is widely used. Weka has been there for quite a number of years and it's also very successful. Keras and of course Python. These are tools that you can use. I know that TensorFlow is very interesting and it's also widely used, just like Weka. Then for visualization, which is also very important in data science, or especially in business intelligence, data visualization tools and library exist. Tableau is one of them, and of course we also know Matplotlib, which is very popular. Where we do programming, especially for data scientists, you must write code, and when you write code, there are very interesting tools. Python is very popular. In fact, it's one of the most popular programming languages for embedded computing. And of course, there's R, which is very close to MATLAB. For those of you who have used MATLAB, I use it a lot. And Julia, Scala, and these are very interesting tools that we use. Statistical analysis tools, everybody is very familiar with SPSS and SAS. Of course, these two are really very popular and very famous. Now, data science approaches. There are 4 important approaches in data science, and it goes this way, from information to optimization. Information simply means collect data and give us information, give us information, so that for this information we want to know. But now, how better can we optimize information and make it more useful or more relevant to business operations? So here we have 4 major approaches to data sciences. The first one is descriptive analysis or analytics. Of course, the question we want to find out from here is what happened, okay? And then when we know what has happened, the simple question is just tell me what happened. And then when you tell me, then I may want to go further to diagnose and say, okay, if this happened, why did it happen? And probably we might want to get some more from inside to inside. Of course, so if I know what happened, then I can begin to look at future and say, okay, will this happen again in the future? I don't want it. So I can do some kind of predictive. What will happen next 5 years or 10 years or in the future? And of course, if we want to make it to happen faster, we optimize. And this is why we do optimization. If I know I'm going to be rich in 10 years' time, what can I do now to even bring it down to 5 years or 3 years so I can optimize? Because I know that I will be rich, I want to make money, and of course, faster. So how can we make it happen? Especially if it's something very rewarding, of course, and this is the idea of how to translate insight to foresight. Of course, what is insight? So this is just simple ability to recall, remember, or recollect an event. And of course, we know this event has happened, so we can recollect it. Then the insight is the capacity to gain an accurate and deep understanding. So when we have better understanding of what happened here, we can begin to do more and try to infer. And of course, this is the capacity to do more when you have good understanding. This is just very close to Bloom's taxonomy of knowledge hierarchy, and say, look, this is the first level of knowledge. Just know that. And of course, you can begin to explore further until you get to the foresight. So insight is the capacity to gain more accurate and deep understanding of something. And of course, you can begin to take advantage of what you know. Then foresight is the ability to see, guess, or forecast. More here, you play the role of an oracle that can guess what will happen in the next 10 years. I remember some years ago before COVID, somebody actually predicted in the next 2 years there will be COVID, but nobody took it very serious in America. Nobody believed it. But 2 years after, it came to pass. I don't know whether it is artificial or real, but we know prediction can be true. So what is the idea of descriptive approach? Description is just mean show me. You can see the example here. I speak and I also show so that you can understand. Seeing is believing. Show me here simply means tell about what happened in the past. So if I give you data, what information can you give me? You can just show me the graph and say, okay, this is the information that we have from here. So descriptive approach uses data aggregation and data mining techniques to collect and organize and, if possible, store historical data and then produce visual results like bar graph, chart, line graph, bar charts, pie chart, dashboard, and of course, more recently, digital storyboards become digital storytelling or board becomes more important. It also uses methods such as dashboard. And many of us who have seen dashboard, we use this a lot in my university and some reporting tools, a scorecard, and data warehousing. Data warehousing is very important for the connotation of data science. We use that to store information, track information, cluster information, analyze, summarize, and then report outcomes. So the second step is more of diagnosis. That's where we explore more. So we want to have better understanding of information coming from this data so that we can use it better. For example, if I have a data, I want to know how can this data be useful for medical diagnosis, for example. So we need to look for more insight in this, not insight from the data. So it helps to understand why an event happened in the past, why this event happened, so that we can control or manage it, it doesn't happen anymore again. So it also reveals the root causes of a problem or trend. What is causing this problem to happen? And then it will also identifies and focuses on factors that are most impactful, not just any factor. So critically, what are the most important factors that causes this and not just everything? Of course, organizations, teams can can usually identify the behavior of profitable customer segment to explain why they are spending more money. So why customers are buying this product, for example, we want to understand why they are buying. So you can tell us they're actually buying. So why are they buying? And then you can do some analytics or analysis and tell us people are buying this product because they are also buying that product. People are not buying this product because the sales of this product, if you do association rule mining, for example, people are not buying more bread because there's no butter anywhere in the store. And then you can tell the manager, please, we need to buy more. We need to stock more of butter because people are not buying bread. Obviously, when people buy bread, they buy butter, or when they buy butter, they buy bread. So this is the information we can extract. And this information can help us to manage our organization more and more. And of course, we can do predictive. What is predictive approach? This one is more complicated in the sense that it uses quite a lot of scientific methods, statistical methods, computational modeling, machine learning to answer the question about what will happen in the future. So this is more at advanced level of prediction. It uses past data, historical data, to also forecast possibilities of the future events or outcomes or behavior occurring in the future. And of course, we can use this marketing team can predict how much revenue will be likely generated with the upcoming campaign. And of course, what product should we recommend, for example? So these are likely possibilities. Then prescription is more of, it's also very interesting because it takes predictive result to more advanced level and say, this seeks to determine the optimum action to be taken to cause an event to happen. So if I want certain event to happen, I say this is what I must do. So it's prescriptive. If we do this, for example, if we want to be here, we have to spend 1 billion this next year. So that's what. So otherwise, if we don't commit these resources, we will get there in the next 5 years. But if we commit these resources, we need to hire this person, hire this category of people, and spend this amount of money, buy this equipment, so that in the next 1 year, we will be where we want to be in the next 5 years. So this is more prescription. It tells what actions have the highest potential for the optimal outcome. And of course, marketing teams can also use it to determine what products to promote in the next season. So this is the outcome. So these are the 4 approaches of data science that we normally want to use. And then we need to understand each of these. If the problem you are trying to solve is descriptive, you need to understand what method you will use and what outcome you expect. If it's diagnosis, you need to decide. You don't mix them together. You need to decide whether it is a diagnosis problem you want to address, and then, of course, what method or techniques or principle you use. And if it is predictive, again, you understand. And then if it is prescriptive, you need to understand what method you require. Now, the idea of professionals in data science is very important because we also want to know, is their career, if I'm a data scientist, if I study data science, will I become a professor in the university or a teacher in school? And that's what most people would probably think. Now, we are saying here that there are many interesting careers that data scientists can and that comes that's associated with data science. For example, I try to give here about 7 of them. Say you can be a data engineer. So it has very prospective careers. And when you study data science, you can work as a data engineer. In fact, these are a recent profession in South Africa that is very attractive. And then the salary of this category of professional is very interesting. Data engineer, for example, what will this person do in an organization? Data engineer will configure data pipelines and support data preparation and model development. So machine learning engineer is also there. These are engineers, or these are people who understand how to develop machine learning models. They are very familiar with methods and techniques in machine learning, such as supervised learning, reinforcement learning, and unsupervised learning. And of course, they can use those tools in this discipline and solve very many complicated problems in the society. So you also have data translator, just like you have language translator. What will this person do? This person will help plan project and communicate results across, irrespective of what the data is saying. He is able to communicate the result. Then we have data architect. What will an architect does? Designs and oversee the implementation of system and to store and manage data for analysis. So this is what data architect does. So He is an architect. He can craft and design tools and technology to support data management. Of course, the most interesting aspect of professional is data scientists, and sometimes you can look at them like statistician. In fact, I call data scientists data oracle because they can look at data and tell you many pictures that the data convey, and I'll be showing some of examples as we go on. So data scientists analyzes data and creates intelligent tools and technology to discover useful information for improving decision-making or process in an organization. Then we have data analysts. This is more lower, and data analysts should obviously be sometimes learn from, just like you have medical doctor and nurse. So this is a medical doctor, a specialist, and this is the nurse always assisting or providing assistance. So this job is more at lower level compared to data science. Then data visualization developer. These are guys who are experts in dashboard. They are expert in visualization techniques and tools. They can develop different tools that will make your website look very attractive, that will make your product very attractive for every people to like it. So that will make your user interface and screen look very attractive, and then invite people, and then attract people to use your systems and technology. So they are expert. It's not usually very easy to develop good product. So you need the expertise of these people to actually create product that people will like. Then, very interestingly, is the idea of data science method, and there are quite a lot of this method. I've tried to classify, or you can generally classify into 4 groups. One, classification category. You can ask yourself, what category does this data or datum belongs to? And of course, to answer this classification problem, there are quite a lot of machine learning techniques you can use. Decision tree is very popular. Naive Bayesian is very famous, and it has been there for many years. Support vector machine came from mathematics, and then this has been there for ages. People use it. K-nearest neighbor. In fact, I met the guy who developed K-nearest neighbor when I was in the UK in a conference, and he was telling me about it a very long time ago when he developed K-nearest neighbor. So he developed the professor from UK actually developed the K-nearest neighbor. Logistic regression is also very important, and of course we know neural network or fuzzy logic or neuro-fuzzy logic, they combine. So I was with Professor Zadeh in the University of California in America before he died. And then I chatted with him about the new work that he's doing on fuzzy logic. So it's really very important. Deep learning, of course, they are more recent. These are more recent methods that you can begin to create more complicated network models that can solve more complex problems. And of course, we know that the wisdom, 2 good heads are better than 1. So the wisdom of many researchers is better than 1. So we can begin to look at example learning. I've done quite a number of research work here as a vice PhD student. And of course, we can look at many of these, and even deep learning. My recent research work, PhD student currently will be finishing this year, is working on example deep learning. So he's using quite a number of deep learning to assemble them and combine them together to solve more complicated problems, and such that the execution time of the algorithm is also very fast. So that is the more interesting work. Then regression here is when we do prediction. We want to know what is the value that can be predicted by this data, and quite many interesting method techniques here or methods. Linear regression, lasso regression, multiple regression, partial least square. My wife is an expert in partial least square, and she also uses for her PhD. Then we have FDL. I'll be showing you some of these later on. FDL, these are rules or laws that we can also use for curve fitting. And this one, FDL, is called first digit law, and FLL is called first letter law, and of course the zip. So later on you see the relationship between zip and the FDL. Then clustering is very important, and one of the interesting problems here is that while we have succeeded, the researchers have succeeded more in classification problem, but here we have not seen much success in clustering. And I'll tell you now, how does this data form category? And of course, we can see there are quite a lot of interesting techniques classify into centroid. Central, I know Professor Joshi has done some good work in this area. Central, we use k-means plus, k-median, quite a lot of k's here, and k-prototypes, and very many of them, k-median, k-modes, quite a lot of them. And of course, recently, 2016, k-set was developed. And of course, fuzzy c-means is there, Clarence. These are all central-based methods. Distribution-based methods are things like Gaussian mixture models, expectation maximization, and so on and so forth. And of course, density-based method, we have DB-scan, adaptive DB-scan, Denklu, optics, and so many of them. And more recently, very interesting, is the idea of message passing. And here we have the only one here I've seen here is affinity propagation clustering. In fact, clustering techniques looks very interesting. I'm doing current work in this clustering. Many of the algorithms here have not been successful. And of course, that the unsuccessful result of clustering creates the gap between classification and clustering. So for example, do we really have to do manual clustering before we can use classification method? No. So if we're able to come out with clustering techniques that we do it more effectively, and of course, we can close the gap between classification and clustering. Of course, here, the problem with many of these clustering algorithms is that they actually take some input like the number of Ks, the number of cluster, which might not be very interesting because users may not always know the number of cluster in data. So there are some techniques that have been developed external to this algorithm, and they will tell you use this method, for example, to first find out if there is to detect number of clusters, which is not very interesting. So the question is, how can we automatically construct a cluster by just passing data as argument, and then the machine will automatically, or the algorithm will automatically determine the number of cluster. Affinity propagation tried to do that, but this has not been very successful because the complexity of affinity propagation is n square. So if you have 1 million data, so you now say 1 million times 1 million, and then the computer is overwhelmed and breaks down. So this has not been worked, but it's a very good idea. So I'm currently working on this project, and I want to construct an algorithm that will automatically solve that problem. Of course, association rule mining, association is very important. And here, we want to find out if relationship exists between a group of data. And quite a lot of this result can be used. We know of a priori algorithms, quite different versions of a priori algorithm. The first one that Agravas a priori that started from the basket market problems. Tatios, Eclat, frequent pattern growth, bit matrices, cross impact, correspondent analysis, multiple correspondent analysis, principal component analysis, and of course, latent direct rate allocation. These are quite many interesting methods that, and more of them can be developed, and more of them are being developed by researchers and authors on a daily basis. So this list is inexhaustive, but I just try to pick some very few ones here. Now, ladies and gentlemen, we have come to the end of data science. I now want to introduce you to business intelligence. And of course, business intelligence, you can see quite a lot of issues involved in business intelligence here, but I would just say very simply, business intelligence is the use of software tools. You use some tools. You are not creating tools. You don't create, you don't develop. If you develop, you're a data scientist. You just use existing tools here to collect, store, integrate, present, and perform analysis of data to make informed decisions. So the kind of analysis you perform here is only descriptive. Can you see now? Data science, we perform 4 different analytics, but for a business intelligence, because most of the guys here are more of managers, so you don't really need too much of statistics here and mathematics. So what they just do here is just use descriptive. So this focuses on what happened. So business intelligence is not interested in prediction. So the goal is just what happened or what is currently happening that organization should address. That's all. So this also helps to guide operational decision-making process and strategic decision planning. So what are the components? The component of, there are 4 main components of, like I show you here, there are quite a number of components, but the most important ones are data warehouse. You need a data warehouse, like you can see here, to store data from a variety of sources, data coming from anywhere. And of course, it becomes very important to use cloud as storage so that you are free from the bottleneck of maintaining different data sources. You can see them here, cloud or cloud forest. So the second one is data management tools. So you need to manage data. Having the warehouse, to manage the data in warehouse, you need some tools or API that you can use to connect or to analyze or to mine or to retrieve data from the warehouse. So you may not even know what the warehouse looks like, but these management tools will help you. Then there's also performance management tool. Here you monitor and then you analyze progress towards achieving some business goals. And finally, user interface is very important. So that people can see, can we deliver this information generated from the warehouse on the mobile device or my smartphone or my 5G phones, for example, or can present it on the dashboard and so on, and then some other visualization too. So I try to compare data science with business intelligence. And of course, the most important thing here, people say if you want to compare things, you must compare apple to apple. It's not always true. You can compare apple with orange, doesn't matter. It depends. What matters is your goal. So if your goal is to prepare fruit salad, then you know that what makes a fruit salad is not only apple. It's apple, banana, and orange, and then and some other fruit. So you can, but in this case, it is good that business intelligence and data science, they are like apple to apple. One is this, the other one is it, but which of these is better? In fact, the taste might be different. This might be sweeter than this, depending on individual. So we compare two of them. And of course, I will not go into detail of this because of time, but there are criteria that we use. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You can see, you can use it even if you want to publish your research paper and speak about them. You can actually use all of this and then use this to classify. Of course, if you want to classify the two things, one and this, you need some criteria, and of course you can do some ranking here if you like. And you can see here that in terms of skill, data scientist is this. And then this is a business analyst or business user. It's more like a user or scientist. Then, in terms of coding, automation is very low. Automation is very low here. In terms of automation, meaning you use this in organization, is very high in business because everything here is automation. You automated it, but here is more of development. So you don't do that. So planning here, decision making here, hypothesis testing, and you identify trends here. So these are really very interesting concepts. Now, what are the business intelligence applications? Of course, you can look at most of those from data science because business intelligence, you have seen now, is a small component of data science. So it's a subset of data science. So you can say that data science is a business intelligence, but business intelligence is not data science because business intelligence is a subset, small aspect of data science. So these are some of the applications. Digital dashboard, community detection is very important, or social networking analysis, and quite a lot of them. But here, I'll be focusing here on the fraud and double detection because it looks very interesting. Now, I try to look at some practical scenario of a manager, and then this is a manager, MD is a manager, and then this person is the data scientist. So the manager will ask, what happened that created anxiety everywhere? So this guy is asking. She doesn't know what's the problem. And then this person will say, we discover a fraud case worth 150 billion rupee in the general ledger. Okay, so this is it. So at this level, we have description. Descriptive analysis is important here. What happened? So this person has to solve the problem. Now, this person discovered this fraud and then can show it to the manager through the ledger, for a picture of the ledger on the mobile device. And that's what will interest the manager. Then the manager can ask for that. Why did it happen? And then the data scientist will say, we are conducting an intense investigation into the case to find out. So maybe at that level, it's not as easy as that because we have to do more investigation. You might even need forensic auditors to come and then do investigation and bring all the documents, 25 years of the company existence, bring all the documents and try to find out when did the fraud started. Maybe the fraud started with taking 10 rupee, 20 rupee, and you may not know until it accumulates. We don't know until we do some kind of deeper analysis at this level before we can know. Then the manager will ask for that. What will be the effect of the fraud organization? What will be the effect? This is will the organization collapse? and not be able to pay workers. So what will be? The manager may want to know. And then the scientists will say, we will know after ongoing investigation. So we will know. So we cannot know now, but we have to do. That's why as you go further, the problem becomes more complicated to solve, more difficult. You don't know at that level. So until you do more investigation and use more tools before you can know. And then the manager wants to know further, how can we prevent a similar case from occurring? See now, this is at the level of prescription. So for this fraud not to happen in this company, we need to put these strategies. But the scientists will say, we will look into the ways after the investigation. For now, because you cannot do anything here when you don't have deeper understanding. You can only solve more difficult problems if you have good understanding of the entire problem. Now, I know we are all teachers here. I want to ask a question. Dr. Joshi, Professor Joshi will help me here. I want to know how many of my audience are listening to me. Practical application scenario, simple test. I'm going to give you a simple test. You can see here this on. You're familiar with dice and coin. I'm not sure. You know dice and coin. I should have put India coin here. And of course, the first question: what are the chances of rolling a dice and getting 5? Who will tell me the answer? What is the answer? Any response? Let me go to. Any response? Professor Joshi, can you tell me who is getting the answer correctly?
Yeah, they will give you answer, no problem.
Give me answer. What is the answer?
They can unmute and they'll talk to you.
Yeah, just tell me what is the answer. Huh?
5 by 6.
1 over 5 by 6. What is the answer?
Saying 1 by 6.
5 by 6.
1 by 6.
1 by 6. Okay, let me see if you are correct. You will see if you are correct now. 1 over 6, correct. So you are correct. Okay, well done. So how many rupees should I give you? 1 rupee. Thank you for that.
We are not seeing your screen, Olu.
You say what?
Your screen is not visible. It's my face looking at in your screen.
You can't see my screen?
Yeah.
Why?
You can minimize this window, maybe that's the reason.
So it's visible. It is visible.
It's visible to everyone. Okay, fine. Go ahead. Go ahead.
Yeah, your machine is having problems. So please,
Yeah,
you can
maybe.
Yeah, okay. The next one. What are the chances that a randomly selected numbers between 1 and 100 is 50? What is the answer?
Visible,
1 second, 2 seconds. What is the answer?
1 upon 100.
1 over 100. Okay, so let's see if you're right.
1 by
Correct.
100. 1 by 100.
Yeah, correct. You are right. 1 over 100. You are very correct. So next one. Oh, you guys are very brilliant. You are tops because Professor Joshi taught you. That's why you are very brilliant. Okay, now let's see this one.
They are brilliant because I didn't take any session.
Okay, thank you. So now, what are the chances that a random transaction has an amount that begins with 3 out of possible 9 digits? What is the answer? One second, 2 seconds. What is the answer?
Is it 1 by 9?
It's okay. So what are you saying? Are you saying 1 by 9?
Yeah.
Okay. It is not 1 over 9. So you failed this one. Okay. So what is the answer? Why? Why is it not 1 over 9? Why? Do you know the reason?
10.
Why is it not 1 over 9? You see, it's becoming more difficult now. You see the way we started with a very simple one. 1 over 6 is very easy. 1 over 100 is more difficult than 1 over 6. Now this one is tough. So we're now going to prescription now. So why is the answer not 1 over 9? This is the answer. The digits do not have equal chances of occurring. So the probability is 3 over 25, not 1 over 9. It will not occur. So when you throw a dice has 6 faces. Only one of them will occur. So any of them has an equal chance of occurring. The same thing with number. Any number between 100, when you open it, show it to people, they have the same chance, equal chance of occurring. So in that case, those two distributions are uniformly distributed, but this one is not uniformly distributed. So you can have a transaction that begins, you can have 10 transactions, and all of them will start with 3. So the answer is 3/25, and you will see later on. What is the source of this probability? Anybody can tell me? It's more difficult now. What is the source of this probability? Okay, now the source of this probability is called the first digit law of Simon Ninkob and Frank Benford. So Benford, sometimes we just call it Benford rule. So I'm going to introduce you to first digit law and how you can use this tool to solve many problems in data science or business intelligence. Okay, so the fundamental is that it's either the distribution is uniform or exponential. And of course, the idea is that the leading significant digit of large numbers in a real data set. So when you take data set such as bank account transaction, the money you have in your bank, your street addresses, collect all the street addresses in Mumbai, okay, or in Chennai, collect all of them, or across 200 cities. That's a master's research project or PhD, a master research project. Collect all the street address across all the cities in India. And then let's find out whether you can fix the curve and see whether those addresses follow this law. And then you can describe the information generated. Survey data, crime statistics, stock price, credit card transaction, purchase order, loan data, customer balances, journal entries, account payable transaction, inventory prices, customer refunds, earthquake debt, distance between head and star, image, face images, fingerprint images do not occur with uniform distribution. So it means that all of these data and many more follow the first digit law. However, data that do not follow the first digit law are things like airplane passenger count per plane, telephone number, your telephone number. Collect all the telephone number in Jalgaon. It doesn't follow the distribution. Data generated by formulas. So when you write formulas, the result can never follow first digit law. Data restricted to minimum or maximum can never. Daily stocking price, data produced. For example, if you take baseball, you understand better now. If you take baseball game, you know that those who play basketball, for example, they are usually tall people, very tall. They are tall people. So when you take basketball, and then the height of the players, usually from 5 feet to 7 feet. This is the rule. So if you have 1 feet, you can never be a basketballer. You won't be able to play. So now, there's no player with 9 feet or 1 feet. A 1 feet player will never play. 2 feet player will never play. If you look at soccer and say, okay, the age of players, you don't see somebody with 1 year or 2 years or even 9 years may not be playing at the level of Premier League. So Premier League players will start from 15 years, for example. So these numbers you collect will not follow the first digit law for some reason, and I've given some reason for psychological factor. So I've given those reasons because why? Somebody who is 9 years will never play soccer. So they don't occur. Now this is the law. This guy is Nimkop first discovered this rule about before Frank Benford popularized it and then do some experiments. So this was the rule. And this man observed that if you look at four-figure table, your four-figure table, usually this guy observed four-figure table and then the first pages we actually won. So because most people will go to the first page, not the end, just like website. When you download from Google, you only look at first 10 web pages. You don't go to the million pages. So it's simply, and that's what the law is saying. So people will always look for the first page and not go to the end, the end of the page. And this is where Ninkob discovered the law. So the law says that the probability that a number begins with a digit 1, 2, 3, 9 is P of this is equals to, very simple. Take any number. The probability that a number start with 1, okay, because 1 is here, put it here. So log base 10 of 2, what did you see there? The probability that a number start with 1, 2, 3, up to 9 is given by this. But what happens to 10, 11, 12, 13, 14? So this law was limited to 1 to 9, which is not generalized. It's very weak in that case. So, and of course, this law says that 1 is the leading significant number in a genuine data set. For a real data set, it will occur with a probability of 30.1. So when you take real data set, genuine, not fake data set, you have more ones as the leading, coming first, followed by 2s with probability of 17.6%, followed by 3, followed by 4. So 9 will have the least probability. Example, the first leading significant digit of 2022 is 2, because 2 comes first. So the leading significant is this, so which is 2. That of 0.0000156 is 1, because 0, 0, 0 is not significant. Only 1 is significant. So it comes first. And 8 is 8, just 1 letter, 8. So this is this example of how to use it. This law can be applied to test whether data that is reported are accurate, reliable, complete, and of good quality. So if your manager say, what has happened? You say there is fraud. How do you know there is fraud? Because I applied this law. That is the idea, to detect. Now, how can we generalize this one to 2-digit case, 3-digit case, more than 1 digit? So the joint significant digit law generalizes the first digit law to the entire natural numbers. So this was done by Hill in around 1985 or so. Hill. The generalized first digit law is given for all natural numbers that start with K, 1, 2, 3, up to end billion. And for the first digit, D1, we always be between 1 and 9. And of course, D2, D3, D4, and so on and so forth, up to K, will be from 0. And this law is given by this. Probability of 2 of them occurring is given by log of 10, 1 plus 1 over summation K equals 1 to K, I equals 1 to K, 10 raised to K minus 1 di. So when you solve this equation 2, you can easily get this one. It's a simple one, just remember this. Okay, log of 10 is 1 plus 1 over this number. So let's see. The probability that a number starts with digits 314, for example, is P of 314 is equal to log to base 10, 1 plus 1 over 314. Very easy, this probability. And that's how to calculate probability. So for 1, if you have 1 digit, put it here. 2 digit, put it here. 3 digit. So the probability of P120, P120 is log 10, 1 plus 1 over 120, and you get it. 2 significant digits correspond to K equals 2. If you have 132, K equals 2, and the original FD corresponds to K equals 1. So when K is 1, see here, when K is 1, you just have D1. When K is 2, D1, D2. So when K is 1, you have what? K is 1, 10 raised to 0, which is DI. Can you see in this formula? So this or this will give you the same result. Now, so when you have, so you are going to have 2 data. So it's a data called fitting, for example. So it means that you have the first digit law data and then the one computed by somebody in the bank account, the real one, the actual one, and this is the expected one. The expected one is given by this, the expected, and then the real one is the one you have in your data. So how do you now detect if there's error if there's fraud or if there's anomaly? What do? You use the chi-test statistics. This is the chi-test statistics. Okay. So if the difference is high, then you alert there's error or there's anomaly. Okay. And of course, FD law has been extended to the case of letters. We call this one first letter law. So the difference is one, there's a rule for that. And then this is also related to Zipf's law. And all of them, FD and Zipf's law, are both power law probability distribution. The three laws have been effectively applied to detect fraud and discriminate genuine data from the manipulated data. So the graph of the law, the graph of FD probability plotted against the digits is exponential or uniform logarithm distribution. Can you see? So this is example of if you take 20 years general ledger, this is what we get. So most of the record that start, most of the amount that start with 1 occur more than 9,000 times in the 20 years general ledger, followed by 2. So this is the shape of the curve. Your curve must go this way. It must go this way. So it's exponential curve, downward exponential. It goes this way. This will always occur most, followed by this, followed by this. So as you go further, it decreases. Even when you have letters, letter A is 1, letter B is 2, letter Z is 26, it goes down. So the same thing. The English letters also follow that. You can also try that for Tamil letters, if you have, or Hindi letters, and see whether all the Hindi letters, that could be a master's project again. Hindi letters will do this. So now, in the case of computer generated, you can see here that computer generated is not the same thing. So this doesn't follow the FD law. Can you see? 1 occur, 4 occur more than 1, which is wrong. So there's a problem. There's a problem. So this is suspicious now. So you will know that fraudsters have used computer to generate number and they want to defraud an account. This is what this one is showing, because we expect that the rule must follow this. So again, manually generated number. So if you do it manually, you was falsify. Like most people, when they do research, they falsify data. So if you take the research data, you can see something that doesn't look like this. So you can see that computer generated data, and this is what? This is manual. So I take this one and this one, I compare this and this using chi-statistics. You will know the deviation is large, so there must be problem. And this is the example of how to use first degree law for fraud, for detection. So now, general application of first letter law. You can use first letter law for lie detector. How do you know? So you can take this one as a PhD work now. This is a PhD work. This is a PhD work to detect if people are telling lies. And then, and of course, you see this one has very important application in the legal code. If you develop a tool that detects whether people tell lies, and then you can use first degree law to know that. Data analysis, this can be masters. Fraud detection, this is also very important. Forensic accounting, taxpayer compliance. Do people comply paying tax in India? You want to find out. You can take samples of data from one government department and try to check whether the distribution follow image steganography. So how do you know if the image coming is not used for fraudster, maybe by fraudster to hide some information? You can detect that. If an image has hidden information, you can detect that. Payment system auditing, indicator of survey reliability. How reliable is your survey? We can do that. Detecting research paper with fabricated data. So if there are research paper with false data, so we know through these techniques. Now I want to show you some of the research I've done in data science, and then this will also be interest you. This paper, this is the first one we did published last year. So the idea of this one is you can see something here. The world economy will change if you can collect electricity from the air. And then the hydro-generated electricity is very costly. So we can move, and of course we know energy is a very important problem in the 4IR, or Internet of Things. So the problem we'll explore here, my master's student came to me some years ago when she was doing her master's and asked me, Prof, I want to charge the mobile device of, the battery of a mobile device, cell phone. I don't want to use ESCOM energy. So how do I do? I said, take the energy from the air. So, and this has become very interesting that this is our system, this is our result, this is our device, energy harvester that takes energy from the air and then charge mobile device. So we have the infrastructure. I just want to show you, the paper we publish so that you can have access to that paper. That paper was published by Applied Science. I'm recently conducting a special issue for this. You can see wireless power transfer using harvested radio frequency energy with magnetic resonance coupling to charge mobile device batteries. And of course, the paper is here. You can download the paper. Okay, you can download the paper. It's free, open access. I like publishing open access now. So and then you can see this paper is very good. So this is the architecture or the diagram of our circuit. This circuit has been implemented, and then there are quite a lot of interesting circuit design principles that we use. And of course, this is the device. So this is the device after deploying it. So we build this equipment. So when you connect, this equipment is taking energy in our lab. This equipment is taking energy from the air. So you just connect your mobile device here, it charges automatically. You don't need cable, you don't need any cable. So what we are trying to do, in fact, we made a mistake. This should have been patented. So my university wanted to patent it, but because we published the result, we could not patent it. So it's just to give telecom and then put this equipment inside this device, and that's all. So that's the work that we did. I'm sure it's very interesting. The second one is we did this research work, and it's computational genomics. So the idea of genomics is that.
Excuse me, sir.
Yeah.
I have one question regarding this. So in this particular,
Which one? The first one? Is it the first one?
Yes, this spectrum sensing where you are doing the charging also. So in this work, you are working with, you are also spectrum sensing and energy harvesting. You are both doing, or you are only just energy harvesting?
Well, what we did is that we use energy harvesting techniques. You can see here, radio frequency energy harvesting. Then, but we also use some equipment like magnetic oscillators. If you read the paper, you will see our architecture and how and the equipment, the resources that we use. And then the architecture is what I've shown you here. So for example, you will need this component A, component B, component C, component D, E, and then F rectifier, and then to convert, to store the capacitor, for example. And then of course you have a voltage regulator. And in fact, the paper is well written. So if you read the paper, which is online, you follow the architecture, you can also design something similar. Or if you are interested, I can connect you with my PhD student. I think she'll be finishing this year, and then you can engage, and then you can see, or you can come down to our laboratory and then come and join us and do something very similar. But
okay,
it's good.
Actually,
it's very interesting. Yeah.
Okay,
in fact, when we were trying to publish the paper, if you look at the open comment, and that's why I also like MDPI, publish your comment. We were trying to hide some information, but one of the reviewer asked us to put all of them. So then he was telling us this is missing. But now, if you read our paper, you will be able to, because that's the idea, you will be able to construct the circuit and tap your energy directly. So what we have not done now is to put our equipment in the device. So once we put in the device, they become commercializable.
Okay, but what I am doing, I am actually working with the cognitive radios, and I'm trying to harvest the energy for the secondary users. What you are doing without cognitive radio? So
our paper will help you. Just go through our paper. Then, if you have engagement, I will link you with my PhD student. You can engage. So you read our paper. Okay. It will be very useful to you. It will give you some concept and some good idea. Because initially, when we started, there's certain voltage at master's level. She was able to capture certain voltage, less than 1 voltage. and that voltage was not sufficient to charge. And then obviously, if you know mobile devices, many of them in medical equipment and even your smartphone, you don't need 240 voltage to charge your mobile device, and that's why you need to translate the energy, excessive energy, and step down. You need some transformer, because the energy that is coming from the normal approach is very high. So you need some kind of step down transformer to actually reduce. So, but if we need just 5 volts to charge mobile device, then why do we have to use the normal electricity? We don't need it, because you can actually take more than that amount from the air, from the atmosphere, because there are such small amount of voltage in the air radiated by radio frequency. So because you have antennas almost everywhere, so the energy is in the air because they are being generated from those antennas that you have almost everywhere. And once you have antenna, you can take some energy from the air and then use it. So especially when the energy is not much, we were able to take more than 6 voltage, which is sufficient to charge smartphones and some equipment, medical equipment. So you can also read our paper and then try to find. I'm happy that you like this work that we have done. So thank you very much. But you can still continue to engage. So I can connect you with my PhD student, and then you can chat with her. But when you read our paper, you can engage with us.
Okay, thank you, sir.
For the question. Thank you very much. Now, the second one is, this project is very interesting. One of my friend, this PhD from University of Tübingen in Germany, and then introduced me to bioinformatics as early as 2002. So when we gave presentation, I never liked his approach. The approach was purely computer science. He was using computer science approach of substring and pattern matching. So to solve problems in genomics. Genomics, you can see, because genomics is very interesting these days, and with genomics, we can even generate storage device and using genes. So genes is very important. And of course, the best way to diagnose and to treat patient is to use to do genomic analysis. So that's a very important topics in bioinformatics. So when one of his students came to do postdoctoral fellow with me, I told him the story that, look, that was 2014. I said, your professor actually used computer science method. I want to use engineering method, data science method. And then I have been introduced to data science back that time. So the idea of data science method is that when we take gene, which is a very long sequence of AGCT, now we have up to more bases now, so fundamental bases. And this is the sequence. Now, and if you want to diagnose, all you need to do is to find the region of mutation, for example. So now, they were doing some pattern matching algorithm using substring analysis. And I said, look, this method will not be very good because it will be very difficult for you to use machine learning or data science techniques to solve this problem. So what we did was to use the imaging techniques. So we started with these imaging techniques. The first model we built, and this is how we represent DNA, okay? So this DNA, for example, will look like this. And with this siloed image, we can understand where mutation lies more. For example, we can say this region. And this is a shape, so we consider the shape from the genomics. And of course, we'll improve the result of this algorithm, and rather than using shape, we want to use textual property for classification. And then we're able to map and get this texture. So this is the way, if you look at human genes, you can see it better the way it looks like. And then a researcher came after our work and validate our work and came up with a simpler method using these techniques. And of course, he just wrote this one in a paper, just 2-3 pages. So now the paper is also published, and you can see the paper here. It was published by PLOS ONE. It has more than 3,000 views now. So and has 17 Web of Science citation. So this is the paper. I can download the PDF, and then we can understand. So you can also try to look at this paper and see the way, if you're interested in bioinformatics and how this data science method works and what we have used it for lung cancer diagnosis. So we were looking for lung cancer diagnosis. And these are the genes that we study. We study about 16 genes here. So, and this is our model that we developed. We developed this model, and then this is the architecture of our system. And this is some of the results for different human genes. And these are some of the results we obtained. And of course, we're able to represent. And one interesting thing here is that we found that for human genes or genomes, all the images that are different genes have different textual representation, which is very interesting. And this simply means that we can get a very good methods for classifying lung cancer, which what we have done, you can see different results. So it gave us very good results, and +1 obviously accepted it. Okay, so that's another work that we have done. Great. I have quite a lot of them, but because of time, I wasn't showing you. This is also very interesting to me. You can see here, this is also data science approach, mining association in monograph data. That data is everywhere in most organizations, but we don't use them. We only focus on big data. Big data will require you to collect data from the air using some sensors, for example, because it's always coming continuously. But there are more interesting data called that data, and many of them can be found. You see, Professor Joshi's office has quite many shelves with many books, but these books contain data. And most of the time, researchers will be looking for data, interviewing people. My wife got a PhD in e-learning, and then she wants to write a paper, and then she doesn't want to go and collect data from people, students, and say, what can I do? I say, take the data from the already published papers. And that's exactly what you have now. Yeah, these are data that she used. Collected several papers. You do meta-analysis, and then you collect several papers. Can you see them now? Sustainability. This you can see the report here. Let me show this article. Very good. So you can see here we use a technique called multiple correspondence. It's a very powerful data science method. Okay, it's a very powerful data science method. See here, this study aimed to apply data science method of MCA to explore hidden association among factors influencing student acceptance of MOOC. So if you want to know what are these factors influencing student acceptance of MOOC, and then what you would do, you just construct questionnaire. We didn't do that. So we said here, result based on data extracted from 54 papers published between 2015 and 2021, with a total, with a valid student response of 19,000 is what we use. So we went through some kind of study papers, collected all of them. You can see them here. We did review of several papers, quite very many. And then we found 54 of them very useful. Can you see these are the 54 useful? And we extracted those information. These are the information we extracted from 54, sorry, not 54, from 54 papers, 54 of them. Okay.
Good morning.
54 of them.
पण रात्री तू दिसत तेव्हा माझ्याजवळ आला तेव्हा पण तू उठलाच होता.
Yeah.
तू संध्याकाळी आला इथे बसला.
Many of these papers are from Asia country, including India. You can see them here. China, Jordan, India, Turkey, Iran. This is where we got all these papers. So we extracted all of them. And then this is the sample of, so these guys have done survey. That's what I say about that data. They've done some survey. And then we don't have to do survey again. We just have to use their own result. And that's exactly what we have done here. And then we use this data, use this data to come up with some interesting result. And of course, these are the results from the data after analysis. And very importantly, we're able to find out, after our analysis, data science analysis, we're able to find out very good relationship between these factors and which ones are relevant, which ones are important, which ones are fair, and so on and so forth. You can see here, you see we also do class categorization of these factors into 4 main groups, categorize them into 4 main groups, and they have very important contribution. And we came out with the one, very few of them that actually organizations can focus on. So this is the way we have been able to use data science method. So I'm almost getting to the end. This is a list of abbreviations that I've used for this work. And of course, these are a list of bibliography that I've used. And of course, this is a question time. And I mentioned here that ideas represent a wonderful manifestation of the functioning of human mind. So if the human mind is functioning very well, it means we have ideas. And when we have ideas, it means our mind is working correctly. If our ideas are not wonderful, then our minds are not working correctly. And of course, human brain is a tool which have answers to every question. So every question should be answered by a human brain, except we don't want to answer the questions. So ladies and gentlemen, I'd like to thank you very much for listening to me. And I will be willing to take questions at this time. Thank you very much. Professor Joshi, thank you for giving me the opportunity to present to the wonderful participants. Thank you.
Okay, thank you, Olu. Anyone want to ask question? Actually, I like one of your slide where you mentioned like that hindsight to insight and to foresight. It was really good to understand the way the decision making is changing. So that's a good insight that you have given to us.
Thank you. Thank you.
So do you think that the human intervention will reduce as we are going from insight to foresight?
Yeah, I want to. Okay, when we move from insight to insight, well, intuition, if you look at intuition itself is a way of solving problem, but intuition should improve. But because obviously I will position intuition at this level, okay, but I will position intuition at this level, but not at this level. Because, of course, intuition is one of the ways, especially managers use intuition to solve problems. So they will tell you, out of these 5 factors, we are interested in 1. So this one is the one that we know, rather than using 10 factors. For example, if you want to find, if you want to choose what can really help us to optimize at this level, and then we will not apply intuition at this level. We said we want to maximize here or to prescribe. Managers will now say, okay, let's brainstorm. And that process is intuitive, okay? And then they will discuss and choose one factor and say, these factors, if we focus on this factor, it will help us here. But in most cases, it may or may not. You don't have the assurance, because when you use intuition to solve problem at this level, at an optimization level, you are not sure, because you are not sure of to what extent will your foresight, you cannot have foresight, to what extent will this work, but you have a foresight that certain things can happen, but you apply intuition at this level, okay, and then you expect that thing to happen here. It may or may not happen, okay, except you can have a valid way of validating this. For example, if you use Bayesian and say, okay, I predict at this level what will happen, and you think, and it will rain tomorrow in Jalgaon, then what will intuition tell us? You say you look at the cloud, you look at some conditions, some weather's condition, and then you predict. But one thing your intuition at this level has not helped you to understand is the interdependency between those decision criteria you have chosen, which might actually impact one another. So intuition will not tell you. So that's why we cannot guarantee whether it will happen or not. But if I begin to apply insight and use more advanced method, for example, that will not just say, okay, yeah, this thing will happen based on intuition, but this thing will happen because, so I can create some reason and have a better scenario and say scenario 1. So you see the way I've been able to improve my intuition. Scenario 1, it will rain in Jalgaon if this happen. Scenario 2, so when I create 3 scenarios, I am sure because of the insight and the foresight that I've I have, and I have better understanding here, because intuition is simply saying you don't have better understanding of what you are trying to do, then you just discuss and dialogue, and that's what intuition tells you at this level. So intuition may not make actions here to occur, but if you begin to improve on your insights and move towards insight and do more exploration, using some more better idea to explore your intuition, then you may be sure that this may likely occur. So we always say likely occur. And that's why I will always propose whatever method you are using, you must also associate your foresight with scenarios, because scenarios will tell you 1 or 2 or 3 scenarios, one of them is likely to happen. So one of them will obviously happen. In that case, you have improved your intuition here based on some other evidence. I'm sure I've been able to answer your question, Professor Joshi.
Yeah, it's good. But it was like the automation will increase. When you go from information to optimization,
Yes, it will increase.
Computer automation will increase. So human intervention will reduce. So you don't want human to get intervene. Human intervention will come down,
yes,
and automation will increase. So when it's
yes,
automated, foresight will be automated. Then
yes,
the questions of ethics will come into picture.
Okay, I agree with you. I agree with you. I agree with you, absolutely.
All right. Any other participant would like to comment, would like to ask question to Professor Olu? Okay. So if we don't have any questions, then we can stop. Thank you, Olu, once again, and
Thank you.
very informative session, and it gave insight to us of what you are doing, and how you are utilizing data science and this business intelligence in your research. So that's a good idea that helps us to focus on our way of doing research. Also, thank you very much.
Thank you, Professor Joshi, for allowing me to speak on this wonderful workshop that you have organized. Thank you very much. I'm really very happy. Thank you very much. Thank you.
Thank
you. So, do you
yeah,
want me to leave?
Yeah, you can leave now.
Okay, thank you very much.
Thank you. All right. So, dear all, we have an extra half an hour for us now today. So we will again join at 12:30 for the that way that will be the last session where we will be giving some technical inputs. So a resource person will be there to deliver talk. Will join at 12:30, and then we will be again gather at 3 o'clock, where we will be having test as discussed yesterday, as told by the co-coordinator Dr. Manoj. So 12:30 to 2:30 will be the last technical session, and from 3 o'clock we will have our valedictory session. In that valedictory session, we wish you to give some feedback, whatever you have in your mind, so that it will be get recorded also. And then we'll have a test so that the formality will be completed. And if there are any other things that we can discuss, then we'll discuss it. So that's the agenda for today. So we'll join again at 12:30, sharp till 12:30. Thank you all.